Perpendicular bisector. Now that we have discussed about constructing the angular bisector, let's see now how a perpendicular bisector can be constructed for a given situation. Construction of perpendicular bisector is the session for today. To construct the perpendicular bisector of a given line. To construct the perpendicular bisector of a given line. Now that we know that a perpendicular bisector is a line which exactly passes through the midpoint of the given line and which is perpendicular to the given line. To recap with, a perpendicular bisector of this line AB would be nothing but a line which is exactly passing through the midpoint and which is perpendicular. Is how we understand the perpendicular bisector. So this line is referred as perpendicular bisector because this line passes through the middle point M of the line AB and this is perpendicular to the line AB. So let's see how perfectly we can draw this kind of a line for any line AB given out there. This session is about construction of perpendicular bisector of a given line. I have a line AB which is given with its endpoints A and B. Now let's see how we can draw the perpendicular bisector. The first rule what we make in perpendicular bisector is I take the compass at pointer A and then by fixing the radius I take the precautionary measure that the radius is more than half. That means I cannot take the radius which is less than half and cut an arc. I always take something till here or here or here which is approximately more than half. So putting the compass pointed at A, I take the radius more than half and then cut an arc. Something like this. Similarly, I do not disturb the radius, but with the same radius, I put the pointer now at B and then from the compass, I cut an arc. Is how we get the two arcs cutting. Is how we get the two arcs cutting. So now we have the arc which is cut on both sides and this is the way I get the two arcs from A and B meeting at this points, say P and Q. They meet at P and Q. Let me join the 2 points P and Q using a ruler. So when I draw this with a ruler, I get a line which is exactly in the middle and perpendicular to AB. Is how the construction of perpendicular bisector defines. So here we get a line which is exactly passing through the middle point of AB and which is perpendicular to the line AB, cutting at 90 degrees. Therefore, this line which is obtained by taking the compass more than half and cutting the two arcs, we get perpendicular bisector. So here comes perpendicular bisector. PQ is the perpendicular bisector which is obtained through the construction process. Let's see the rules in step-by-step process. The first rule is For the given line segment AB, we take the compass with radius more than half. Using compass, cut an arc from point A such that its radius is more than half of length AB. This is very important. This is taken as precautionary measure, because if you don't take the distance more than half, the two arcs never cut, and there's no question of forming the perpendicular bisector. In order for the two arcs to cut, the rule is that the arcs must fix with the radius more than half. So here, using compass, cut an arc from point A as we get here, such that its radius is more than half of AB. Cut an arc from A on either sides of AB, because we don't cut the arc only on the top but on either sides of the line AB, here and here. Therefore, using compass, cut an arc from A on either sides of AB such that its radius is more than half of AB. Next, cut an arc from B on either sides of AB with the same radius. Now here I do not disturb the radius from A, but with the same radius I repeat the same process, but now from point B. Cut an arc from B on either sides of AB with the same radius. The two arcs meet at P and Q. As can be seen, the two arcs meet at P and Q. Now, join PQ and extend on both sides. I join PQ and extend on both sides. Therefore, I observe that the line PQ as obtained is the perpendicular bisector of line AB. Is how we understand PQ being the perpendicular bisector of the line AB. Perpendicular bisector constructed through the following rules. Now that we have seen the construction of an angular bisector and the perpendicular bisector for given line AB, now let's see how we can construct an angle or a perfect angle of 60 degrees using the construction properties. This session is about constructing perfectly an angle of 60 degrees. To construct an angle of 60 degrees. So let's see how we can construct an angle of 60 degrees. But the rule here is interestingly, if we have a protractor, we can directly construct, because in a protractor we have the 60-degree angle which can be identified. But this session we are going to construct an angle of 60 degrees. More interestingly, protractor is not allowed. That means without the help of the tool called protractor, we will try to construct an angle of 60 degrees using strictly the construction properties, proudly in mathematics. So let's see how to construct an angle of 60 degrees without using the protractor. So here I take a line segment AB. Now at this point A, I would like to construct a 60 degrees angle. So let's see how we can do that. So in order that I construct an angle of 60 degrees, I just first put the compass at A and draw an arc of suitable radius. So here I draw an arc which cuts the line AB at some point D with some suitable radius from the compass. Now with the same radius, without disturbing the compass, I now put the pointer at D and cut with the same radius. So with the pointer at D, I cut with the same radius, and the new arc which is formed clearly cuts the old arc at this point, say some C. So here I have a point C where the new arc cuts. Let me just extend this line and then I get this line which cuts here at say C is extended further. So here the angle which is formed at A is exactly 60 degrees, perfect, without using the protractor. So some of the angles can be constructed without using the protractor by using simple techniques of geometrical properties of cutting an arc with the same radius, cut an arc and join the two arcs, join the 2 points, and then we get 60 degrees. So here is what I get, 60 degrees. So let's see the rules in brief. The first rule is draw an arc of suitable radius from point A which cuts AB at D. As clearly seen, this cuts AB at D. From D, draw another arc with the same radius. From D, draw another arc with same radius. Which cuts the older arc at point C. Clearly this cuts the older arc at point C. Now here we have 2 points A and C which are joined and extended. Join A to C and extend the line. So we get here a line which is this. Therefore, angle BAC is 60 degrees. Angle BAC is perfectly 60 degrees. So whenever we want to draw an angle of 60 degrees, we use this simple technique, which helps me in perfectly drawing an angle of 60 degrees. More importantly, without using a protractor, is how I understand the property concept. Now let's see some properties the construction of triangles with certain conditions. So now that we have learnt how to construct an angular bisector, how to construct a perpendicular bisector, and how to make the different properties as discussed in the construction process. So let's see now how we can draw a triangle whose base is given, whose base angle is given, and sum of other two sides are given. So this session is about the construction of a triangle. To construct a triangle whose base and base angle and the sum of other two sides is given. So let's see how we can construct a triangle whose base and base angle are given and the sum of other two sides is given, are all given in the process. So let's see this special case. So here I have a base AB of certain length. So I take that given length using the ruler and I draw a line segment with that fixed measurement using a straight ruler. So once the line segment AB is given and drawn out here in the plane, next is the base angle which is taken. Say my base angle at A is given, so I make an angle using the protractor and then I get the angle out here. So here is the base angle. So once I get the base angle using the protractor pointed at A, then after this let's take the sum of two sides. Say in this case I draw a rough figure A, B and C. In this case this angle and this distance are given, and so here length AB is given, angle BAC is given, and sum of other two sides, that is AC plus BC, is also given. Is how we have all the three things given. So let's see how we can construct a triangle just with the base and the base angle and sum of two sides which is given. So what I do is AC plus BC, the sum of other two sides which is given, is taken as the measurement. Say if this is given to be 14 centimeters, I take the compass with the length of 14 centimeters and cut an arc. So here I cut the arc with the distance of AC plus BC. So that distance is cut an arc and it cuts this line at D. Then I join D to B. I just join the two lines from D to B. Then I take the angular bisector at B. So we know how to draw the angular bisector as taken in the previous case. So I draw the angular bisector at B by cutting an arc, and then I get this cutting at C. So here clearly we say that the triangle which is obtained here is the required triangle. So I clearly get this to be a triangle which is ABC, which is obtained here. So this is the triangle. triangle ABC is the required triangle, is how we get when there's a base given, base angle given, and sum of two sides AC plus BC is given. I first draw the line AB, the base, and then make an arc or make an angle with the protractor, and then take the measurement of AC plus BC. From A, I cut with the same measurement, it cuts at D. I join DB, then I get a bigger triangle ABD. Then I find the angular bisector at B, which cuts this line AD at C. So this angular bisector which cuts at C will form a triangle ABC as represented by the dotted region. And this dotted region is the triangle ABC and is called the required triangle. Given the base and the base angle and sum of other two sides, a triangle ABC can be constructed using this process. Construction of triangle ABC. Now that we have seen how to construct a triangle with the base and the base angle as given out there, now comes the question of what if the sum of sides which was given in the previous case is now reduced to difference of two sides which are given. This session is about constructing a triangle whose base and a base angle is given and the difference of the other two sides is given. Let's see the session. So the session is about to construct a triangle whose base and base angle are given and the difference of other two sides is also given. So let's see how we can construct a triangle if there are difference of the other two sides which are given along with the base and the base angle. So let's see the construction process. So here the base which is given is taken out here. AB is the base, and after making the base AB, I have the base angle which is taken out here. So at A, let me say I have the base angle which I draw using the protractor, and then I get this ray. Now the difference of two sides, say for example if I take the construction diagram as a rough work, ABC, this is given, or this is A, B and C, and this angle is given, then the difference of two sides, say AC minus BC, is given. Now this I take it as case 1 because there is a possibility that BC minus AC also might be given. That is, here the case 1 is that AC is assumed to be greater than BC. There is a possibility for AC to be less than BC, which we take exclusively as the second case. So the first case dealt with constructing a triangle is that this measurement AC is assumed to be greater than the length BC. So in this case, the value which is given out here for the difference of other two sides is taken on the compass and we cut the arc. So here we cut with the same measurement of the value as given in the difference of two sides, and using the compass I cut out here. So this cuts the ray at point D, and now I join BD. So after I join BD, I get a straight line which is like this. So for this line BD, I draw the perpendicular bisector. So we all know how to draw the perpendicular bisector. Take the pointer, take more than half and cut an arc. I get a perpendicular bisector out here. So I get this to be a neat ruler and a diagram. So here is D, and here I want to draw the perpendicular bisector. So here, let's say, here is the perpendicular bisector for this line. Which cuts exactly at certain point. So let's say this perpendicular bisector meets the ray at A or at C. So here this is assumed to meet the ray at C. So I get the point C cutting the ray at point C. I join BC with a straight line. And then I get a triangle ABC, which is clearly obtained as given by the dotted line. This is how we get the straight line. The dotted line represents the triangle ABC, which is obtained where the base angle and the difference of two sides is given. We can construct a triangle ABC. Is the required triangle. As how we identify the triangle ABC with the base angle and the difference of two sides as given. With the case 1, AC assumed to be greater than BC. Now let's see how we can construct a triangle whose base angles are given and whose perimeter is given. This session is about constructing a triangle whose two base angles are given, not the third base angle, but only the base angles are given and the whole of the perimeter, that is, sum of all sides of the triangle are given. To construct a triangle whose base angles are given and the perimeter is given. So let's understand what are the given things through which we can construct. So here, if I assume a triangle, we have only the base angles which are given, but we don't have the length. So we cannot assume the length, but we assume that the base angles are given and AB plus BC plus AC is given, angle A is given, and angle B is given, is how we have all the three different things which are given in the triangle ABC. So let's see how we can construct a triangle whose base angles are given and the perimeter is given. So let me take the perimeter length which is given out here as the base. So I take the base initially such that this is nothing but the length xy is such that it is the perimeter of the triangle. So I draw a line segment base xy which is nothing but the perimeter of the required triangle ABC. Now from x and y I draw the base angles A and B which are given to be the same as I draw here. My base angle A value is drawn as an angle out here, and my base angle B which is drawn from y is drawn from here. Now from this we draw the angular bisectors of x and y. So once we get these two angles, then I draw the angular bisector x at x, and I draw the angular bisector at y. At y. And these two angular bisectors meet, say, at point A. That means the angle which are equal cut at the point A. Now, after I get the point of intersection of the two angular bisectors at x and y which meet at A, now I take the perpendicular bisector for XA. So let me take the distance XA or AX and draw the perpendicular bisector. And let me take the perpendicular bisector of AY, say, which cuts at B and C. So here the perpendicular bisectors from AX and AY meet the baseline XY at B and C, as can be seen clearly in the diagram. So I get 3 points ABC which are joined. So I join AB and AC and I get ABC, which is a triangle. So here I get the required triangle. So ABC is the required triangle. Triangle ABC is the required triangle. Is how we construct using the angular bisectors and the perpendicular bisectors. So if base angles are given and the perimeter of the whole triangle is given, that is sum of all sides of the triangle is given, we can construct a triangle using this process. Take the base with the measurement of the perimeter of triangle. From X, draw an angle equal to angle A. From Y, draw an angle equal to angle B, and then draw the angular bisector of X, and from Y, draw an angular bisector of Y, and then they meet at point A. So from XA, draw the perpendicular bisector, and for line segment AY, draw another perpendicular bisector. Clearly the two perpendicular bisectors meet the baseline XY at B and C. The points of intersection of the perpendicular bisector and the baseline XY are B and C. Join AB and C, which forms a triangle as represented by the dotted region. So in this case, triangle ABC is the required triangle, which can be constructed only if the base angles are given and the perimeter is given. Constructing a triangle ABC with the rules.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.